In order to achieve spray transfer, we will need to change our machine settings. For this demonstration, we have selected 1.2 mm electrode wire, and we shall be welding upon 8 mm mild steel plate. The three main factors influencing whether you will achieve spray transfer mode using 1.2 mm wire are welding voltage of at least 23 volts, a welding current of at least 250 amps, and no matter what size wire you use, the shielding gas must contain at least 80% argon. Using the current wire feed graph supplied in your notes, it can be seen that in order to achieve 250 amps using 1.2 mm wire, we will need a wire feed speed of approximately 7 meters per minute. The wire feeder can now be set to deliver 7 meters per minute as the starting point for our exercise. Next, we need to set the welding voltage, where again we need to first establish a starting point figure. Again, it must be emphasized that the settings we have made are purely starting positions, and in all probability they will need adjusting to achieve the desired spray effect. The third factor affecting spray transfer is the shielding gas, which, as we mentioned, must consist at least of 80% argon. The shielding gas flow rate can now be set, in the manner described earlier, to deliver between 12 and 15 liters per minute. To conclude the primary settings for spray transfer, you need to adjust the electrode stick-out, which for spray transfer is double that of short-circuit transfer. An average setting would be approximately 16 to 20 millimeters beyond the nozzle. Metal preparation for spray transfer is exactly as mentioned in an earlier section, namely that rust, mill scale and other surface impurities must be removed. Parallel lines are ground onto the surface of 8 mm steel plate in order to follow when we weld. The handling of the welding gun is performed in exactly the same manner as you learnt with short-circuit transfer. A 2 to 3 mm arc gap is required, and when this has been set, the welding hood is dropped and the trigger is pressed. The arc is established and welding begins. The nozzle to work distance must be steadily maintained as you move along the weld line. The speed of travel must be controlled in order to maintain a weld pool of around 8 or 9 millimeters, which is 6 to 7 times the wire diameter. Filler material is deposited very quickly with spray transfer, and you will find that you will have to move the gun much more quickly than you did with short-circuit transfer. At the end of the run, the arc is drawn back onto the bead and welding stopped. The pool must be shielded with the post-flow gas until it cools. Assuming that all machine settings were correct and that the arc length and pool size had been properly